and welcome to the session on simple interest and compound interest. This is brought to you by Handaka Funda. The basic difference between the two types of interest is that in one case, principal remains constant. That is the case of simple interest. If the principal keeps on changing, that is the case of compound interest. Let us take an example. Let's say I loan 100 rupees to two people A and the rate of interest is 10%. But there is a difference between the two. To A I am giving at simple interest and to B I am giving at compound interest. What will happen? Simple interest will be 10% on 100 rupees, that is 10 rupees. Compound interest will also be 10% on 100 rupees, that will also be 10 rupees. As you can see, there is no difference here, but the difference will come in from the next year. Let us look at what happens in the second year. In the second year, simple interest will be 10% on 100 rupees, it will still be 10 rupees. But compound interest will change. The interest earned in the first year will get added to the principal. So the effective principal becomes 110 rupees. Interest in second year is 10% of 110 rupees, that is 11 rupees. Let's look at the third year. In the third year, simple interest will still be 10% on 100 rupees. 10 rupees. Compound interest will now be on the increased principal, that is 100 plus the interest 10 rupees for first year plus the interest 11 rupees for second year. That means interest will be 10% on the total amount of 100 plus 10 plus 11, 121 rupees. In third year, my compound interest earned will be 12.1 rupees. As you can see, just over a small period of 3 years, total interest earned in simple interest case is 30%, and in the case of compound interest, it is 33.1%. As you can see, interest earned when the rate and the principal are same is lot higher in the case of compound interest. Let us look at the formulas. In case of simple interest, it is given by principal into rate into time by 100. However, for compound interest, we first calculate the total amount, which is given by principal into 1 plus rate by 100 to the power n, where n is the number of years. This is the amount in case of compound interest. If I want to calculate the actual compound interest, it would be the amount minus the original principal. If you remember the previous case, the difference between the simple interest and compound interest at the end of the first year was 0. What will it be at the end of second year? That is given by P R square by 100 square. Let us see how the formula for difference comes. Simple interest in case of 2 years will be P into 2 into R by 100 because the time period is 2 years. For the compound interest, I first need to calculate the amount, that is P into 1 plus R by 100 whole square, which will be effectively P into 1 plus 2R by 100 plus R square by 100 square. This is my amount after 2 years. Compound interest after 2 years will be if from the amount I remove the principal. That is effectively 2PR by 100 plus PR square by 100 square. We want to find out the difference between the simple interest and compound interest after 2 years. So if you look at both the figures, if I remove the simple interest portion, that is 2PR by 100 from compound interest, I am left with the formula PR square 100 square. You can use this formula directly when required. The restriction being the principal and the rate should be the same, and this figure gives me the difference after 2 years. Let us look at a few examples. What will be the amount if the rate of interest are different over the years? Let's say for the first year the rate is R1, for the second year the rate is R2, and for the third year the rate is R3. In this particular case, the amount in case of compound interest will be given by P into 1 plus R1 by 100 into 1 plus R2 by 100 into 1 plus R3 by 100. As you must have realized by now that if I change the order of the rates, it is not going to matter in my final amount. My final amount will be the same irrespective of whatever is the order of rates of interest. There are a few other cases as well. For example, if the interest is calculated every half year or every quarter, half yearly or quarterly, then how will our formula change? If my rate of interest is R for a period of T years, amount is given by P into 1 plus R by 100 to the power T. That is provided it is compounded annually. What will happen if it is compounded half yearly? My amount will become P into 1 plus R by 2 divided by 100 to the power of 2t. What I have done is the effective rate becomes half of the original, the time period becomes double of the original. What if it is compounded quarterly? The amount will become P into 1 plus R by 4 by 100 to the power 4t. Here effective rate of interest has become 1/4 and the time period has become 4 times the original. Let's say they are amount A1 and A3. Can you tell me which one of these would be the biggest value? You may pause the video if you like. The relationship among these three will be A1 is less than A2 is less than A3. This will happen because when the interest is getting compounded quarterly, it gets compounded way more often or way more frequently than in the case of half yearly or in the case of annually. In this case, you are getting interest on interest. So the more interest you get, the better it is. If it gets compounded more frequently, the better it is. I'm sounding like Shylock in time. Stay with us for the next video on simple interest and compound interest.